Hello, and thank you for joining Advanced Cooling Technologies for this lesson on heat pipe basics. A heat pipe is sealed under vacuum with a small prescribed amount of working fluid. During non-operation, the fluid is contained inside the wick structure that lines the inner diameter of the heat pipe. When a heat source, such as an electronic component, generates heat, the fluid vaporizes at what is known as the evaporator section. The fluid vapor quickly spreads to the other end of the heat pipe using pressure generated by the temperature difference. At the opposite end, known as the condenser, the fluid gives up its latent heat, which is rejected to an external heat sink. The fluid then returns to liquid form, and the wick structure passively pumps the fluid back to the evaporator using capillary force. By utilizing liquid and vapor phases, the heat transport is extremely efficient. Because it's a closed-loop system, heat pipes operate continuously and passively, creating a very reliable component in your thermal management system. Now we'll go through a quick demonstration on heat pipe thermal conductivity. In this demo, we'll examine the heat transfer capability of a copper rod versus a heat pipe. On the outside of both samples, there's a paint that changes from green to yellow when the temperature exceeds 40 degrees C. We'll now place the copper rod into the hot side of the unit and let it heat up. The hot side is well above the 40 degrees C color change temperature. Copper has a thermal conductivity of 400 watts per meter K, which is high for most metals. You can begin to see color changing as the copper conducts heat away from the heaters below. Now we'll place the heat pipe into the hot side. Notice that the heat pipe reaches steady state almost instantaneously with minimum temperature gradient compared to the copper rod. Now we'll move both the copper rod and heat pipe into the cooler side. The heat pipe simply changes the direction of the thermodynamic loop and reaches the lower temperature steady state in seconds, while the copper rod struggles to reach that steady state temperature. ACT would like to thank you for joining us. Hopefully everyone learned a little bit about the advantages of heat pipes. For further information, please visit our website or give us a call at any time.